last time. All right, welcome to Wednesday of week 10. One of our new handouts today is a whole bunch of code. Go ahead and flip toward the middle of this packet, if you could, to a file called speller.php. So what I went ahead and did was rewrote problem set 5, the spelling program, in PHP. And what I'd like to invite you to do is take a look for just a moment at this so-called source code. And to be sure, it looks a little different. But start glancing at it from line 1 all the way down, because I quite literally translated it line for line as best I could from C, with which you're hopefully still familiar, into PHP. So notice at the top I defined this constant called length. Notice that I defined this variable called words in all caps. And already there's a slight difference there, right? Now all of a sudden I have this $sign in front of words, but we'll see that that's actually pretty common here. I'm checking argc again and printing out its usage. I'm initializing some variables, it seems, called startup, lookups, and sizing to 0. I've got these benchmark variables as well. And if you keep scrolling through this, you'll find that it's almost identical. It's certainly identical functionally. It's almost identical syntactically. But perhaps the most glaring difference, and I'll harp on this to get us started, is just that variables don't seem to have data types, or at least explicitly mention data types. Right? What kind of data type was that variable called words in problem set 5? This thing up here that gave us the default dictionary. What was the data type in C? Not file, just this, I don't want to say the answer. The string, right, a char star. And some of those numeric values like lookup and sizing and startup, well, those were just floating point values, recall. So we don't seem to have any of these primitives explicitly mentioned. And it turns out that in PHP, even though there's kind of sort of this notion of data types, you don't have to, with PHP, specify what the data type of a variable is. And rather than just say the name of this variable, you need to reference it by way of a $sign in front of it. So for now, we'll summarize the differences between C and PHP solely in terms of those differences, which is only to say that the leap that you're about to make today and on Friday from C to PHP really is not all that far. And in fact, this is pretty typical when it comes to picking up some new language, even though there might in fact be some syntactical differences, some different functions and names therefore. At the end of the day, it's pretty much the same stuff, just implemented ever so slightly differently, but with which you can tend to solve the same problems. So suffice it to say that this program, Speller, does in fact run, if I run it at the command line as speller.php, just like our C version did. And in fact, I'm going to go ahead now and point out one last thing. So notice at the top of this file, I'm not saying sharp include, so another minor difference. I'm saying require dictionary.inc. So dictionary.inc in about 2 minutes time is ideally going to be an implementation of dictionary, much like we did for problem set 5. Well, let's see if we can do this in fewer than 5 to 15 hours here. All right, so I'm going to go ahead and open up a file called dictionary.inc. Actually, I'm going to move the temporary one. So dictionary.inc. .inc is just a convention. We could have named this dictionary.php instead of dictionary.inc, but the convention is that you, when you know you're going to be including a file, similar in spirit to a .h, you can just call it .inc. So I'm going to do a couple of things here. So the very first thing most of you did in your implementations of a dictionary was to have some kind of global variable. All right, a global variable called, say, size. So I'm going to initialize a variable called size to 0. And then I'm going to initialize another variable called dictionary to be some kind of data structure. Well, just to keep things simple initially, I'm actually going to initialize this data structure to be an array. So again, a slight difference versus C, but know for now that when you want to declare a variable in PHP, all you do is specify the variable's name, and then you assign it to the return value of a function called array, which conceptually returns an otherwise empty array. But now the syntax is actually going to be pretty similar. So what were the 3 main functions in problem set 5 we needed to implement? All right, so load, check, and size. All right, let's pluck off the easiest of those. So let me go ahead and declare a function called size. To do so in PHP, we're simply going to write function size. All right, it's not going to take any parameters, so we keep the parentheses much like we did in C. And all I need to do now is return size, because that file, speller.php, just like speller.c did, is going to call this file's function called size, and it's going to return that value. One little aside, though, not to get us distracted, it turns out that you do deal with global variables slightly differently in PHP. So because I want to return a variable that's not local, but instead global, I first need to tell PHP that this $size was actually declared globally. But otherwise, that's the only difference here. So now we're done with size. Well, what about load? So load, recall, took a one argument called dict so that we could actually then load every word from that dictionary file. And what did we go about doing to open and read these lines in? Well, what many of you guys did was just something like this. So file pointer gets fopen of the file called dict. We'll open it in read mode. And then what did you proceed to do once you had this file opened? Well, some of you, and this was one of my suggestions on the bulletin board even, called fscanf, which turns out this exists in PHP as well. You called it with that file pointer. You said read a string from that file and read it into a variable called word. Now, notice here, too, I don't need to even pre-declare my variables in PHP. So already we see some relaxation of some of the principles that we've been preaching. But turns out this can be convenient, even though it can sometimes get you in trouble if you're not careful as to what you're actually loading into memory. So what I'm going to do here is I'm going to say, so while this does not equal 1, because recall that fscanf should return the number of things that it parsed from the file. So this is all old school from the world of C. And what I'm going to simply do now is I'm going to add to this array called dictionary this word. So this is a really neat trick in PHP. Rather than maintain, and actually, let me take one step back. What I'm actually going to first do here is initialize, just to be clear, a variable called I. And what I'm going to do here is store in this array at location I the word I've just read, and then I'm going to increment I. So now it's almost identical to C, conceptually. So I'm just going to keep iterating from I all the way up to the total number of words in the file, and I'm going to plop these things in the dictionary. And the very last thing I'm going to do in this program is then call fclose of file pointer. OK, so would you agree that this has the effect of loading into this array called dictionary every one of the words in this file, assuming I haven't told you any lies? Yes? Question?
You don't have to specify any size for the array?
No, you don't have to specify the size of an array. And this is a wonderful thing, because if there's one thing every one of you in this room, myself included, has done likely way more than once, is overstep the boundaries of your arrays. So what's nice in PHP, as well as in other languages, is there's no more of this pre-declaration of the size of your array. In PHP, you will find that arrays are going to be dynamic. They will grow to fill the amount of data that you want to plop into them. Well, now let's do a very naive implementation of the check function. Recall that the check function's purpose in life is to check whether a given word is a word. And actually, I'm going to scroll up for just a moment, because recall that I need to specify that the dictionary array that I want to put all these things in is, in fact, global. OK? And actually, I'm going to make one other change, because I didn't need to do this variable called I. Recall that I initialized size to 0. So what I can really be doing here is just reusing that same variable. And now I can kill two birds with one stone, if you agree. OK, it's initialized to 0 up top, remember, just with that. And now I'm putting it into the array at location 0 initially. Then I'm incrementing size so that it gets plopped into the next index on the next iteration. And now I'm going to do a really lame implementation of the dictionary, right? I never quite mastered linked lists. I never quite mastered hash tables, tries, any of this stuff. I'm just going to iterate over this array looking for the given word. So what I'm simply going to do is this. And this is a bit of neat syntax. So for each, let's do, first I have to say global. Now I can say dictionary, because I want to iterate over this array called dictionary. And now, because dictionary is an array, what I can do is say for each dictionary as dict word, what this has the effect of doing is setting up a for loop that on every iteration is going to grab one element from the array called dictionary and temporarily call that word dict word. So this is equivalent to using a for loop where you iterate from I equals 0 to whatever. But on each iteration, this one line of code has the effect of just plopping into this temporary variable called dict word each word from the file. So with that put forth, what does it take to check if the given word is in fact in the dictionary. What do I need to do? So if, yep, exactly, we need a condition. And it turns out the syntax is almost identical. So if the given word that I'm trying to check equals the current dict word, what should I immediately do? Yeah, just return true. Otherwise, do I want to return false? Not yet, right? Otherwise, we'd only check one word in the file. But if I get all the way down to the end of the function and I still haven't found the word, would you agree that you return false? OK, so now let's see if I did this correctly. And I'm going to do a bit of a white lie for time's sake. So I'm going to use actually the version that was pre-prepped, even though I'll put this online. So what I'm going to run now is speller on, say, that file called austinpowers.txt. Done. So what was that? 2 minutes, like 4 minutes maybe. Implemented problem set 5 using PHP. All right, it's kind of remarkable. But what this suggests is that, oh, damn, why did we teach you C? Maybe we should have planned this a little better. But the point is the points we're trying to make is a couple. So one, I think only when you begin with something very low level like C do you understand the implications of various design decisions, and can you really master, I think, a lot of these fundamental constructs. But the fact of the matter is, especially when you're trying to solve real world problems, whether it's in computer science or in bio or statistics or economics or whatever domain you actually have, some, or even a student group, you have some problem that you think can be solved by a computer, it's nice generally if the language doesn't get in the way of you getting real work done quickly. And what we'll see quite quickly today and on Friday is that with other languages, PHP just one of them, can you achieve some of the tasks that you guys have really been tackling from a very conceptual and very intellectual level very easy when you let the language do more of those features for you. In fact, I'm going to take one step here toward a better implementation, because what's the running time asymptotically of this implementation of check? What's the running time asymptotically? Come on, this is easy, right? So it's just big O of n, right? It's linear because in the worst case, the word I'm trying to spell check is like zoo or whatever that last word is in the dictionary file. And because I'm looping over the dictionary from the first word to the last word by way of this for loop, which granted didn't exist in C, but it does get the job done in PHP, I might have to look at all n words, all 140,000 words in the dictionary. So can we do better? Well, what was the data structure that many of you guys used for your own problem set 5? So a trie, or even more commonly we saw, was just a hash table with those chained lists and such. And in theory, or ideally, a hash table's lookup time of a word is what? Constant, right? Ideally, it's constant time, but in reality, you sometimes do have collisions, and so you had chains. But it was still pretty darn fast. Well, it turns out that with PHP, as well as with some other languages, you can also treat arrays as though they were hash tables. You can treat arrays as what are called associative arrays. So in the typical sense, when you are talking about an array, you have this mapping from the 0th element to some word in a dictionary, from the 1 element to some other word in the dictionary, from the 2nd element to some other word, and so forth. Well, in a sense, this is already conceptually like a hash table. You can hash to the ith location of your array, and out pops a word. The ith plus 1 location, and out pops a word. So generally speaking, in languages like PHP and Perl, there's this notion of an associative array, where you don't have to use numbers as your indices, but you can use whole phrases or whole words unto themselves, which is to say the following. I'm going to leave my definition of dictionary as an array, but now I'm going to treat it not like a traditional array, but like one of these associative arrays, where I can use not numbers for indices, but words themselves. All right, how am I going to do this? Well, rather than just plop into the dictionary in my load function the actual word at the current location, what I'm instead going to do is flip things around. I'm going to use not a number, but the actual word as my index. And then I'm just going to say true. So what is this doing? So rather than storing at the 0th location the word foo, we're flipping things around now conceptually, such that now I'm storing at location foo the value true. And if I do this again for every other word, I'm going to store at the location bar the value true. I'm going to store at the location baz the value true. Now, this might take a little bit of a mental leap to realize all of a sudden arrays don't need to be indexed by numbers, but they can be indexed by words, because it's unclear how you figure out where to go in the array if you're not just using a number, but are instead using a word. But the thing is, with PHP, with Perl, with other languages, you don't have to care about that. The language takes care of it for you. So notice what I'm essentially doing is flagging as true a bit to tell me which of the words in this file I've seen before. That is to say, I'm setting a bit to true for every word that is in the original dictionary file. So what does that mean for my check function? Well, no longer now do I have to iterate over the whole darn dictionary to find the word. Rather, I can rip all of this out, and I can just do the following. If dictionary at the location called word equals true, well, return true, else return false. Done. My hash table is implemented. Question?
How does it know where to find it in memory?
Short answer, doesn't matter. It knows how to find it in memory. And so and now I'll answer sort of more fairly. So the way PHP works, as we'll see, is that PHP programs aren't just run usually by writing their name at the command line. You have to tell the computer on which you're running a PHP program what program to use in order to execute it. All right, so the difference here is as follows. When you compile a C program, you get something like a.out, and you can just type a.out and run it, because that compiler made a file whose bits are arranged in patterns that the CPU understands. PHP, by contrast, is what's called an interpreted language. Not a compiled language, but an interpreted language, which means if you want to run a PHP program, you have to ask someone to run it for you. You can't run it directly on the hardware, so to speak. And the program that we are running, or that we are asking to run Speller, it turns out, is this crazy long line. So we have installed, long story short, on nice.fast, a program called PHP, which is an interpreter, which means that that line of code says, because this is PHP, it's not zeros and ones designed for x86 that can just be executed on the CPU. I need to interpret those and translate them to zeros and ones. And so what that line is doing is it's going through the whole file and effectively, through a lot of more intelligent manipulations than we'll get into in this course, converting that or translating that into actual machine code, or it's translating it to as much. So the result is that that program PHP is the only one who has to know about how to figure out how you get from foo to true, or bar to true. And you, the programmer, don't need to care. In reality, what PHP has probably done is someone else who wrote the PHP interpreter probably implemented that kind of syntax to support this notion with a trie, or with a hash table with chained lists. But the point is that you don't have to do that anymore. Yeah? On nice.fast, yes, and we'll emphasize this in the problem set and in sections, but yes, you will need to put that line of code atop any PHP program you write so that the computer knows how to actually read what is otherwise just ASCII text. Yeah?
Practically speaking, if you were running this program that we just wrote in PHP over and over, comparing its runtime to like one of the most effective ones that was done before, would this be noticeably slower?
Oh, that is the perfect segue. So thank you for having set me up for this excellent answer now. Yes, if I run Speller on Austin Powers and take a look at the total running time, notice that it's just under half a second to spell check this one file. Well, I went ahead and in advance pulled up the big board, because remember that the big board shows you not just your totals for running all those benchmarks, but also for individual files. And just to ignore these crazy guys that did all that funky pre-processing, I'm going to scroll down to this guy in 15th place, me, and notice that my version in C, per the rightmost column here for total running time, is damn faster, the version that was written in C, even though I'm running it on the same nice.fas machine. So generally speaking, when you use an interpreted language, you pay a performance cost because someone needs to be translating effectively all of that PHP code into something that the CPU can understand. And that guy, needs some amount of time to do that, and so you pay for it in terms of performance. So generally speaking, when one really, really cares about performance and writing the most optimal software possible, whether it's some of maybe even Facebook's back-end stuff, maybe it's Google's back-end stuff, the stuff that's not just presenting web pages but doing interesting data manipulations, you tend to write it in a compiled language like C, or even Java, as opposed to these interpreted languages. Though there are tricks with which you can speed things up. But the takeaway, though, so maybe that's a nail in the coffin. But what is the huge upside of my having implemented this dictionary program in PHP? I mean, my God, done, right? And we leveraged the idea of a hash table, which conceptually you hopefully understand. And in just, what, 12, maybe 20 lines of code, we've implemented that same program. And that's compelling. Now, I introduced this example of PHP just to in terms of Speller, just to relate it to something you've already seen, and to emphasize that if you look after class at speller.php, it's damn similar to speller.c syntactically, even though I used in my dictionary some new syntactical tricks. But we will now be migrating today and on Friday to using the same language, PHP, but in the context of web pages, and using it to generate not misspelled words, but rather Xhtml, the language in which web pages are written. So that's where our story left off on Monday. We introduced a bit of Xhtml, the language in which web pages are written. And I said also, and we don't care for our purposes today or in this course what the real distinctions are between XHTML and CSS, because we're just using XHTML and CSS, particularly for problem set 7, to allow you to implement web-based software. And to do that, you need to be able to create web pages. You need to be able to create a GUI, a graphical user environment. And it's pretty easy to pick up, right? Take to heart, perhaps, the fact that my math CA spent maybe 30, 40 minutes teaching me this language. Not all of it, certainly, just the bare basics. And then I Googled, well, there was no Google at the time. I Alta Vista'd the other informations, the holes that I wanted to fill in, and we'll encourage you to do as well with your classmates and with the teaching staff over the next few days. But I did want to point out a couple of tricks. So you'll recall that we did a couple of hideous examples, one of which ended up looking like this. Okay, so I did this using some pretty basic XHTML, but then I also downloaded an image and we added that tag, and at the very end of class I added a link to CNN so that we now have pretty much the basic building blocks of web pages as we know it, albeit with no sense of aesthetics. Well, you'll see in problem set 7 that we actually make use of some pretty useful conventions, which is to say the following. Take a look at this very simple web page. This is just a hello world web page. And notice that, and it's very dark and blue to read, but it says in blue, hello world. What kind of web page is this going to create for me aesthetically? What's it going to look like if I open it in IE? What do you think? And there's a lot of distractions there, but at the end of the day, there's very little content. Yeah, so it's going to have a link called hello world, mapping using that very last tag we introduced on Monday to the domain that I arbitrarily picked, world.com. So what does this thing look like? Well, let's go ahead and open this file called css.html. You have a printout of it as well. And it, too, is pretty darn boring. But just to give you a taste of some of the things that you can pick up in section and on your own over the next week, notice the kinds of things you can do with CSS. Notice that, and I've highlighted it here, this is the same file we're looking at, and I've grayed out everything except this new line. So this new line of code, is essentially telling the browser, include, this is the equivalent in XHTML of sharp include, if you will, include a file called styles.css, which is just a text file that's got a bunch of style sheets in it, so to speak. And this is a bunch of code that controls the aesthetics of a web page according to certain rules. All right, and I won't dwell so much on the specifics because it's best taught, I think, by example and not so much by lecture. But notice that the file just looks like this. So in this file, and it's got C-like comments at the top, I mentioned this word body. Now, we've seen that before. The half of a web page conceptually is the body, and the other half we said was the head, but very little goes in the head other than maybe the title. And now, apparently, something else that goes in the head, it turns out, is this link tag, which just says, go include this file in this page. Well, take a wild guess, frankly, as to what these two lines of CSS code are going to do to the body of my web page. It's going to make the background what? Black, all right, and it's going to make the color of the text white, all F. So let's take a look. If this is in fact true, yes, it is true, but something is different. The text seems to be blue for reasons we'll get to in a moment. And it's only blue because it's a link. But notice, we can very quickly devolve this thing back into that hideous website. If I go ahead and change the middle two digits there to FF, what's that going to do to my web page? Whoops. Background body. Oh, what do you know? What's going on? All right, let's fix this. Styles.css, css.html. And today's other lesson is going to be file permissions. So actually, good example. That was intentional. So, so recall that it's important for anything you want to put on the web, it's got to be world readable, right? It can't be kept private to your account. And the problem set will remind you of these commands, but it was this cryptic chmod command that I wrote the other day, which essentially says make styles.css accessible to the world. So let me go back into styles.css and change it back to the original, because you're quite right that it was not what we promised. And I hit reload, and now, in fact, it's inverted. Black background and white text, except for links, which, as you know from the web, tend to be a different color. So let's now change this to something more hideous, just to prove that this is, in fact, a true story. And now we've got our second most hideous web page. All right, now let's just scroll down for a minute, because just to give you a taste, and again, only a taste of what CSS can do, take a look at these two elements. So what is this element here, this CSS apparently doing? Yeah, so it's making links what color? Well, red. We saw that by example, and FF0000 is an RGB code, so that means a lot of red, no green, and no blue, and thus is our link red. Well, what if we want to change this thing to be invisible, so you can have a hidden link on your home page? Well, what if we do this? Make them both green, refresh, ooh, nothing here, unless you know where the big example is. Now, why is it that this thing just became huge and ugly? Well, notice what I'm doing is hovering over the link. Well, why is it changing its appearance? So a neat trick with CSS, and CS50's website does this so that links get underlined only when you hover over them. Notice that what I decided to do, and it's dark blue, so it's tough to read, but this says A:hover. So what this is saying is that if you hover over an anchor tag, that is a hyperlink in the web page, well, it changes color to red. It becomes a huge font size, 72 point, and text decoration, you just have to know what that means. It means don't underline it if it's none. So notice the effect is, again, hover over it, red and huge, no underline. Red and huge, no underline. Well, I like underlining. Let's turn that back on. So I'm going to say text decoration, underline, save, and now. Oh, yes, it's a green underline. No, is that? Oh, OK. So one other important lesson that we will teach today is that CSS is called cascading style sheets. And what cascading implies is that there's a sort of conceptual hierarchy, where if there are two style sheets that match a certain element, the one that came first one inherits from the other's properties. So this is to say, if I actually want to get rid of the lack of underlining. Oh, that's OK. I see what you're saying. All right. So what I'm going to do is I'm going to change the color of this thing back to the hideous red. And now notice that it is, in fact, underlined in red. OK? And I'll defer just to experience for some of these lessons. Because, again, our goal here today and on Friday is not to dwell on how do you make web pages, how do you make pretty web pages, how do you code up CSS. Because, frankly, one of the lessons here is bootstrapping yourself. Conceptually, I think it's useful to know just generally how these things work. But then it's a matter of just looking things up and asking someone how to do things and looking at examples like even CS50's website as to how to accomplish new tricks. Yeah?
Let's say that you forget the color code for black or white. Can you just put black or white as background or color?
Sure. So there are some commonly used codes where if you forget what the code is, it understands, a typical browser understands 16 or maybe 20 some odd words instead of color. So by all means, though frankly, HTML color code, look at all of the options we have. Someone made a whole web page with all of the codes that you can use. So that, too, is a common trick and useful thing to keep in mind. Damn, I keep spoiling the surprise. All right. So what else can you do? Well, just to give you a couple other building blocks, take a look at the following example. So you have a printout of this as well. But here's a file called table.html. So again, all the stuff at the top is the same. Right? So even though these files might continue to look a bit like Greek to you right now, notice that most of them are copy-pastes of the previous examples, and then I've just fleshed them out a little bit with some new details. The new details in this example is that there exists something called a table tag in HTML or Xhtml. What this allows you to do, quite obviously, is define a table like you can do with Excel, like you can do with Microsoft Word, a grid of rows and columns. And the way, long story short, how you do this is you say, browser, give me a table with a border that has like one line for every edge. Here comes, browser, a table row. Hey, browser, here comes table data, aka a cell, aka a column. OK, here comes another one. Here comes another one. Well, what's inside each of these cells? Well, notice the only real data is the stuff that's not inside the tags, but rather just there raw. So notice this is going to print a row of the number 1, 2, 3. This tag conceptually says, hey, browser, hey, browser, hey, browser. That's it for this table row. That is close tag. And this is saying, hey, browser, open another row. So the end result is going to be that we have 3 rows because we have 1 chunk of code, 2, and 3. And then each of those guys has table data, table data, table data. So the kind of grid that we ultimately get is, all right, clearly we're doing something with CS50 finance. I will no longer open web pages in advance. And we open table.html, and wow. Underwhelming, but structurally helpful, because it turns out the tables will prove not only useful for a surprise we have for you for problem set 7, but also for laying out web pages. And by that, I mean the following. Notice that this table, beyond just creating a grid, has also laid things out structurally for us. And even though this technique is beginning to fall into disuse as other languages and tricks are beginning to supplant it, it's still quite useful and simple, which is why we'll rely on it. Because notice what I can do. If I change this border equals quote unquote 1 to maybe 10, well, you might guess that this thing's now just going to have an even bigger border. But if I go in the other direction and change it from 10 to 0, notice that it goes away entirely. And yet the code is, or the content is still laid out in a nice way. So much of what you see actually on CS50's website is actually laid out for historical reasons and for various technical reasons using tables. And in fact, let me show you one thing. If I go ahead into not our dummy account here, CS50 stud, but if I actually log into CS50's website, let me point out that these lessons we're trying to teach are ones we're actually applying. We, too, in the CS50 website, use a file called styles.css, which is just an ASCII file that contains a whole bunch of cascading style sheets. And you could have been looking at this all semester long, because the upside and downside of web development is that a lot of the code is by nature available to the world. But frankly, there's not all that much intellectual property behind things like that. So, and the surprise. So notice here, and we did this very briefly in our staff meeting the other day, suppose that we wanted to change CS50's website in one fell swoop, because we're just so tired of all this crimson, and we really like the green links we learned about in class. And I reload our page. And now the entire website has been changed. And this speaks to the power, so to speak, of CSS. I can change one line of code in one file that's being included by every file on the website, including not only this page, but say the final project page has green links now. The section page has green links now. So there's this idea of centrality that you get with CSS, which is just very powerful. And perhaps so that those who are still sleeping have a what the heck kind of wake up later today, we'll leave that on for a couple of hours. So what else can we now do with this? Oh, actually, I promised that we were going to let's see, not just the colors, but oh, the tables. So also in CS50's website, whose framework is a little too complex to walk through in great detail, notice that here is apparently some Xhtml. I'm looking at it with my text editor, but that collectively implements this web page. But I'm going to do a search, and notice that the very first tag inside our website's body is, in fact, a table. So let me change the border from 0 to 1, and also mess with the website now. And it's subtle, but notice now the top of the web page has a grid around it. So it turns out that even though this looks like one big contiguous image, it's actually one image here. then the color crimson, and then another image it turns out over here. And the reason for this is so that no matter how big or small your computer window is, that red bar essentially grows to fill the page dynamically. So that's one trick for why we used a table there. Well, let's not use that table now, but let's fast forward to this next table. And don't worry about the specifics here, but let me change that border to 1 to show you yet another table. So here's now another table that's laying out this image with that red bar. Let me turn that off and fast forward a bit further in the file to this table again, the third table in this website. And now you can't really see it because it's faint, but notice that the rest of the page is in one huge table. Here's a right-hand column, and this whole thing is a big left-hand column. And I don't want to dwell on this because I don't want the takeaway to be making web pages is about making hidden tables. It's just a trick that actually has some benefits and some disadvantages, but you'll see it in problem set 7 in this surprise we have in mind so that we can lay things out invisibly, but things are where you want them to be. And it's a nice thing so that you don't have to use the equivalent of hitting the space bar to lay things out. So suppose now that you're pretty savvy with Xhtml, you're feeling pretty good about yourself, the web pages look good. Is there a way to check the correctness of your own code? Well, it turns out that you can check Xhtml for correctness. And we've not really done this with C because there aren't necessarily some easy tools to do this with. But you can run a web page through this website, validator.w3.org, which looks pretty simply like this. This is hosted by a group called the W3C, the World Wide Web Consortium. They're housed down at MIT, down the road. If you've ever heard the name Tim Berners-Lee, the guy who invented the World Wide Web, well, he is a member of the W3C. This organization is the group that standardizes a lot of the languages used on the internet, one of which is Xhtml. So if I want to check whether or not my table is actually valid Xhtml, I'm just going to copy my URL on people.fast, surf over to this validator, paste in my URL, and click check. And it is, in fact, good. And you can ignore for this semester the notion that it says tentatively all the time. That's because of a nitty-gritty detail we're going to gloss over. But the fact that that bar is green is a good thing. Notice instead if I break that file. So if I go back into table.html, which looks pretty clean, and I forget, for instance, to close that row, which we said on Monday is bad, since you want to close everything that you open. And now I go ahead and revalidate this page. This is not valid Xhtml. So this is actually a useful debugging tool, especially as your eyes begin to acclimate to this stuff and help you find errors, because otherwise a browser might start to behave in unpredictable ways. Let's see actually if we can confuse the browser. So the browser with the correct code looks like this. All right, and that's what we wanted. Now let me start butchering the file. So get rid of the table row. And let's see what IE does. All right, so IE doesn't seem to complain. And this is why it's frustrating sometimes developing websites, because browsers tend to be fairly forgiving these days, because people do make mistakes. Well, let's butcher it a little more. So now I got rid of all of that. So now it's starting to get a little messy. And this might not necessarily be invalid. It just means that I have more columns in this row than in this one. But let's break it a bit further. Get rid of that. Let's get rid of the body altogether. And I mean, this is why people write such sloppy HTML and web pages underneath the hood, because browsers are so forgiving. The C compiler, GCC, was never this forgiving, right? It's incredibly nitpicky. But the lessons we'll continue to try to preach is that you do maintain some structural integrity when writing this stuff. So use that as a tool. We will certainly use it as a tool when looking at your code. So now let's do something more interesting. So now I'm going to take as fact that you guys know how to make web pages, right? You seem to be catching on pretty quickly. You might not know how to write up some CSS or these whole web pages from scratch. You might have to look at one of our handouts or copy paste one of our examples, and that's fine. Frankly, that's what I did in the basement of the Science Center all those years ago with the CA. So that's how you begin this process. But now let's actually use this stuff not for making ugly websites, but rather to actually make software and make tools. So know now, and again, this will be recapped in section and through the problem set, know that there is a way in web pages to take user input. And you obviously know this. If you use Google, you fill in a text form, and then you hit the search button, and then you get back some search results. It turns out that you can define these in this language, Xhtml. And for now, just know that they look like this. If you want a text field, know for now that you just say, open bracket, input, give the thing a name so that this variable, a text field, is effectively a variable that you're trying to pass to the likes of Google or someone else. And what type of field is that? Well, it's going to be a text field. If you instead want one of those password fields like Facebook has where you don't see your password, but you just see ... for every character, well, that's not a text field. It's just a password field. And that just tells the browser, don't show the text, show those dots instead. Well, if you want a checkbox, same deal. Open bracket, input, name equals whatever you want to name this variable, this input, and then say type equals checkbox. Notice that because a checkbox doesn't really have this conceptual notion of starting and ending, it just all sort of should happen at once. Recall that we need to open and close this tag at the same time with that / at the end of the open tag. But remember that from Monday perhaps. Radio buttons, these are these mutually exclusive things. You can pick this option or this option, and if you pick one, it unchecks the other. That's what a radio button is, those little circles. And then, of course, drop-down menus. If you want an actual drop-down menu that lists perhaps all of the dorms in the yard, well, you would write code like this. A select menu, it's unfortunately inconsistent with the notion of an input tag, but it's called select. You give the menu a name, and then inside of the select tag, you put one or more options. This first one appears to be blank, and that means the thing will be empty by default, which aesthetically tends to be nice, rather than just assuming by default that everyone's in Matthews by just showing the first one. But then we have Matthews in the list, Weld, and then I ran out of space, so that's it for the dorms on campus. Well, let's actually use this for interesting purposes. Well, what I'm going to go ahead and do is open up Google here. So notice that Google, it's getting slightly more complicated over the years, but it's still pretty darn simple relative to everything else that's out there. It has a big text field, and then it's got at least one button. That's generally called a submit button. It's also got, for historical reasons, this I'm feeling lucky button. And I actually read this neat, kind of amazing article the other day, which noted how many millions of dollars Google actually loses nowadays when people click I'm feeling lucky. I, for one, have never, ever clicked this button. But there are people that do. And when your revenue is in the billions of dollars, you know, 0.1% of people clicking that button and thus not seeing ads and being whisked away instead to the first course on, or the first link on computers, tends to hurt their ad revenue. But they keep it there because it makes them not evil for some reason, I think was the lesson. Anyhow, here's Google. And now let's go ahead and not click I'm feeling lucky, but click the default submit button. So I'm going to click Google search, and now watch, it's small, I know, but watch the URL at the top of the page. We're going to google.com, and then it looks like /search HL equals EN. I'm going to assume that's not really interesting, but then an ampersand, then Q equals, so there's something interesting. And you've probably noticed this kind of thing before, even if you never cared to think about why this is happening. But the means by which a web page, a browser, that is, can pass a variable, can pass user input to a web server. One way is via its URL, where you submit that data, so to speak, to the URL, and then you append to that URL a question mark followed by variable equals value, ampersand, variable equals value, ampersand, variable equals value for any number of variables that you want to submit to the website. So the neat thing is now that we can actually leverage this truth to implement our own Google. So let's call this mygoogle.com. Actually, I'm going to cheat and copy hello world so that we have a framework. Fakegoogle.com. And now I'm going to chmod it with that esoteric command. And now I'm going to open up fakegoogle.com. So it's just hello world right now for the moment. But I'm going to go ahead and add the following. I'm going to go ahead and say I want a form in this web page, the action of which, that is the destination of this form, I'm actually going to copy and cheat and take Google's destination rather than have to re-implement the search engine myself. The method I'm going to use is get. And though I didn't dwell on this the other day, I did write in all caps get on the board. And that was, I claimed, the message that a browser is sending from itself to the remote server. And so I'm going to tell this form, use that so-called get method. Now inside this form, I'm going to have an input type equals text. And the name I'm going to give this thing is, I have to be careful. Well, it looks like Google is expecting whatever I type to be called Q, presumably for query. So I'm going to say name equals Q. And then I'm going to close this. Below that, I'm going to put a line break. This is just the Xhtml command for line break here. Move to the next line. Hit the carriage return effectively. And now I'm going to have input type equals submit, which is just going to give me a generic submit button. So this again is called fake, oh, not fakegoogle.com, but fakegoogle.html. Let me go ahead and go now to, let's go back to my website here, fakegoogle.com, or fakegoogle.html is here. Now that's not quite nice. That's not what Google looks like. So let's tweak this ever so slightly before demoing it. What I actually want to put is everything centered. So I'm going to say div align equals center, because I just happen to know from my CA that that actually works. I'm going to indent everything just to keep it pretty, even though that's not strictly necessary, much like C. And now it's nice and centered. And now, actually, that's not quite like Google. So let's use an H1 tag, which means header, like a big heading in a newspaper. And we'll call this fake Google and H1. All right. And that automatically, I'll put a line break there to make it explicit. There we go. Fake Google. OK. Now, I'm going to go ahead and type a query, computers. Submit query. Wow. So I'm doing pretty well today, right? Problem set 5 in like 4 minutes, Google in 1 minute. So now we've implemented our own web page that, granted, is submitting to someone else's website. But again, it's just using these basic building blocks, which, again, if you don't remember them off the top of your head, not a big deal. Go look at our examples, look in one of the online resources. And even though it's still a little cryptic, functionally, it's pretty simple. All we're doing is asking the user for a variable's value, and then we're submitting that value to a website. Well, now let's expect a bit more of ourselves, right? It's not really that fair to just punt and let Google do all the interesting work. Let's now start writing a form that takes input like this, but submits it locally to my own web server, and I will deal with the processing of this data rather than letting someone like Google process that data for me. So to do this, we need something other than HTML, because XHTML is just a markup language. It's all about aesthetics and presentation. We need something that's logical. We need a true programming language. So henceforth, you can become a bit of a computer scientist snob. If any of your friends say they know how to program, and what they mean is they know how to use Dreamweaver, or they know how to write HTML, it's not a programming language per se. So we need a programming language, and fortunately, we've got one, right? We got PHP, which it turns out can be used and is primarily used for websites. Turns out you can use C, but I will offer now that it is a nightmare trying to implement dynamic web pages using C, just because it's not really designed with that kind of use in mind. But PHP is. So the first PHP-based web page that I'll show you is not called hello.html, but it's called hello1.php. And notice now that this is terribly simple. So notice that that file is almost identical to hello.html, which was that first trivial demo that we whipped up just to say to the world, hello world. But there's one key difference. What's different about this file? Right, so it has the PHP file extension, so good. So now there's a second thing that's different. What else? Yeah. Yeah, so this is the so-called shebang. And you know you're a geek when you start having words like shebang, which refers to sharp bang. This is the sharp single. Bang is computer scientist speak for exclamation point. So if anyone ever says shebang, it means write that. And then what it's putting is the path on nice.fas to this thing. So what was this? Now it's called php-cgi, but conceptually, what is that first line of code referring to? What's it referencing? So it's the interpreter, right? So not only do we need to tell nice.fas, turns out we also need to tell www.people.fas what program to use to show this page on the World Wide Web. Because notice now what happens. If I go back to my directory with all these demos, and I go ahead and click hello1.php, again, we have a little error there. So I'm going to fix this with a little arcane command, hello1.php. Now I'm going to refresh.
You deleted the bang.
Oh, did I? Ah, thank you. Oh, it doesn't need to be 755. Come on, come on, come on. Hello, not the way we've set up nice.fa. Hello1.php, come on. Yeah, it's 700. All right, fix this on the fly. CS50 stud. No, hello1 is 700. Come on. Sorry? No, it doesn't need to be. It runs setuid on our systems, but I'll do it. But watch me be proven wrong here. OK, so that's why. Sorry, slight delay while David fixes this. Hello, oh, OK. OK, hang on. FTW here. All right, it's alpha. Come on. Come on. What a horrible ending to lecture this is going to be. OK, David will fix, and David will explain what's about to happen. Pub local alpha. Why is that doing that? One last thing. Sorry. We'll fix it. I hate classes like that. OK, so what should have just happened before the bell rings is as follows. The web server, upon being asked for the file called hello1.php, would look at this file and say, oh, there's a shebang at the top of the file referencing a path to a program on the system which I will use to interpret this file and then display it, which is where we'll pick up on Friday.